Okay, so I want to do number 5, part D, which is square root of 3x plus 1 minus square root of x minus 1 equals 2. Now, we're looking at a situation where we have two radicals, and our usual algorithm is to isolate a radical and square both sides. So we're still going to do that, we're just going to have to do it twice. So first thing, I would isolate that square root of 3x plus 1. It's kind of the uglier of the two radicals. So you got square root of 3x plus 1 is the square root of x minus 1 plus 2. Now we've got this thing isolated, we can square both sides. Now the trick is, on the left hand, it's easy, right? You've just got 3x plus 1. The right hand side is what everybody wants to mess up. You've definitely got an x minus 1, and you've got a 4, but what else have you got in there? Don't forget your cross term. Remember, when you square something, you get twice the product as your middle term. So you're going to get 4 times the square root of x minus 1. So we can collect some like terms. I've got an extra x on this side, so I can subtract that off both sides. And I've got an extra minus 1, I can add that to both sides. And I've got an extra plus 4, so I can subtract that from both sides. So collect up like terms, and what I've got is a 4 square root of x minus 1 on this side, and what, a 2x plus 2 minus 4 is minus 2 on this side. Now I would go ahead and at this point just divide everything by 2 to make the numbers a little cleaner. So you've got x minus 1 is 2 square root of x minus 1. So we're in the same situation we were before. We need to isolate a radical, because we have one left, and square both sides. Now this is already isolated enough, so I would go ahead and do it as x minus 1 squared is equal to 4 times x minus 1. You notice that 2 needed to get squared. So I've got x squared minus 2x plus 1 equals 4x minus 4. And collecting like terms, if I subtract 4x from both sides and add 4 to both sides, what I'm going to get is x squared minus 6x plus 5 is equal to 0. Now I think that's going to factor. So you've got, what, x and x, probably 5 and 1 will do it, x minus 5 and x minus 1. So we get two possible solutions out of this, which is x equals 5 and x equals 1. Now remember, when you've got a radical equation, you do have to check and see if your answers work. So let's plug these into the original equation and see if we can make it work. We had square root of 3x plus 1 minus the square root of x minus 1 is supposed to be 2, right? So let's try it. If I plug in x equals 5, what I get is a square root of 3 times 5 plus 1 minus the square root of 5 minus 1. Now 15 plus 1 is 16, and I'm subtracting off the square root of 4. Square root of 16 is 4, square root of 4 is 2, 4 minus 2 is in fact 2. So when you plug in the numbers, you do get 2, so x equals 5 works. Let's try another one. The other solution we got was x equals 1. Now if I plug this in, I get square root of 3 times 1 plus 1 minus the square root of 1 minus 1. Now that is the square root of 4 minus the square root of 0. And it looks like it's also going to work. This is square root of 4 is 2, and that's what we needed. So you get two solutions this time. You get x equals to 5 or 1.